Hello everyone, welcome to Flip-Flop Data. This video is in continuation of the earlier videos on hypothesis testing. Please do watch the earlier videos to gain complete knowledge. In this video, I will cover one of the much debated topic, that is p-value and its importance. So continuing with the topic, let me explain p-value in detail. Why p-value is so popular? Why not critical value? So here lies the answer. P-value is also called as probability value. Most of the statistical software provides p-value rather than critical value. P-value provides us more information compared to critical value as far as rejection or non-rejection of H0, that is null hypothesis, is concerned. So we will see this further. So we will consider our motorbike mileage example, which I have considered in earlier videos as well, probably the first part, and I will reiterate the hypothesis statement. So our null hypothesis H0 is mu equals 60 km per liter and H1 is mu is not equal to 60 km per liter. So this gives us a two-tailed test. So we have population mean represented by mu naught, which is equal to 60 km per liter. Population standard deviation, that is sigma, is 5 km per liter. Sample size n is 50. Sample mean x bar is 62 km per liter. Significance level alpha is 0.05 and confidence level is 95%. We will talk about confidence level in later part of the video. So using this, let's compute our test statistic score. So our test statistic is x bar minus mu naught divided by sigma by root over n. So when we fit all the values in the formula, what we get is 2.83, because 62, x bar is 62, mu naught is 60, sigma is 5, n is 50. So when we compute this, we get a value of 2.83. And since sample size is 50, which is more than 30 over here, so according to central limit theorem, here the sampling distribution of the test statistic approximately follows a normal distribution curve. And since this is a two-tailed test, so our test statistic will be distributed on both tails of the distribution and it can be denoted as plus minus 2.83. And the critical value or the cutoff value for the standard normal distribution from Z table for a two-tailed test at significance level of alpha, which is equal to 0.05, is given by 1.96. So I will show you how this is computed as 1.96. So for this, let us consider Z alpha. And since this is a two-tailed test, first we compute 1 minus alpha, which is 1 minus 0.05. So this gives us 0.95. And for a two-tailed test, what we do is 1 minus alpha divided by 2. That gives us 0.475. What we do now is we search this 0.475 in the Z table extracts. I will show you. So this is our Z table extract. We search for 0.4750. It is here. Corresponding to this, we see the row and column. So here corresponding to 0.4750, row value is 1.9 and the column value is 0.06. So this gives us 1.96. So this is the one. So now to take decision about null hypothesis, what we do is we compare the calculated value of test statistic with the critical value. But before that, let me show you this same information through a normal distribution curve. So this is our normal distribution curve. Alpha is 0.05. On both the tails, we have the rejection region. So this alpha becomes alpha by 2 for both of the tails, and the z score which we computed is 1.96 for the right tailed, and for left tail it is minus 1.96. As we know, mu is 60. Z always starts from 0 at mean. So test statistic what we computed is 2.83. We have 1 minus alpha, which is our non-rejection region, and it is equal to 0.95. So what we see over here is our calculated value of test statistic is 2.83, which is greater than the critical value 1.96. Critical value in the sense z score critical value 1.96, which means that the calculated value of test statistic lies in the rejection region at 0.05 level of significance, and we reject null hypothesis. So we conclude that this sample does not provide us sufficient evidence in favor of the claim. So we may say that the average mileage of motorbike is not 60 km per liter. Hence, here the null hypothesis is rejected at significance level of alpha is equal to 0.05. But there might be a smaller level of significance value alpha at which the null hypothesis can be rejected. This smallest level of significance alpha is known as the p-value. So hence the p-value, how do we define it? P-value is defined as it is the smallest value of level of significance alpha at which null hypothesis can be rejected using obtained value of test statistic. So let us see this through a distribution. So I'm considering the same motorbike example with different significance level, and actually I am considering 3 significance level over here, which is denoted as alpha 1, alpha 2 and alpha 3. Here alpha 1 is 0.05, alpha 2 is 0.0048 and alpha 3 is 0.0040. And the computed Z score corresponding to alpha values are plus minus 1.96, plus minus 2.82 and plus minus 2.88 respectively. So we had computed our test statistic in our motorbike example earlier as 2.83. So here in the first case where alpha is 0.05, the computed Z score is 1.96 and the test statistic is 2.83, which is greater than 1.96. Hence the T statistic or test statistic lies in the rejection region, and based on this H0 is rejected. In the second case, I will consider alpha 2 as 0.0040. In this case, the computed Z score becomes 2.88 and test statistic is 2.83, which is less than 2.88. Hence, the test statistic lies in the non-rejection region as it is lesser than 2.88. And based on this, H naught is not rejected. Now comes the third case where I am considering alpha 2 as 0.0048. So the computed Z score in this case is 2.82 and test statistic is 2.83, which is greater than 2.82. Hence, the test statistic lies in the rejection region, and based on this, once again our H naught is rejected. But what we see is beyond this point, if we decrease alpha value any further, then the test statistic will become less than the computed Z score and will lie in the non-rejection region, and we will not reject H naught in that case. Hence, this is considered as the smallest value of alpha at which H naught can be rejected, and it is called as p-value. I hope this is clear to you. So one important point to consider here is the smaller the p-value, the more significant your results are, and vice versa. So now last we will discuss about confidence interval and relation between confidence interval and testing of hypothesis. So how do we measure confidence interval? Confidence interval measures the degree of certainty or uncertainty of our inferences on the chosen samples. So how do we denote this? So we have level of significance as alpha. Confidence interval becomes 1 minus level of significance multiplied by 100, which gives 1 minus alpha multiplied by 100. So this is the way we find out confidence interval. So in our above case where we considered alpha as 0.05, our confidence interval was 1 minus 0.05 multiplied by 100, which gave us 95%. So thus what we see here is we can use three approaches: critical value, p-value, and the confidence interval for taking decision about null hypothesis. And these examples demonstrate that we may arrive at different conclusions from the same data depending on what we choose as our significance level alpha and the confidence interval. So in practice, we should make our hypothesis and set our significance level before we start collection and exploration of our data. So with this, I conclude on hypothesis testing. Please keep watching my videos. If you have any queries, please drop it in the comment section and I will be happy to answer them. Thank you. Don't forget to subscribe.